Okay, well the capacitors are in now to sort this Sony out. As I say, I can't really find anything else wrong with it apart from that ribbon cable, and I did have a dodgy capacitor, so it's lending itself to being recapped. So that's what's going to happen. It's going to be a nightmare. It is literally going to be a nightmare. There's so many. I mean, I don't need actually all of these, but I need the majority of them. Some of them came in packs of 5 and I need 1. Some came in packs of 5 and I need 4, so touch and go. 0.01s, I had to buy 100 of those, so that was the only way I could get hold of them. But they're mainly Nichicon, a couple Panasonics, and the 0.1s RS Pro. So they're all good quality, high temperature caps. Gone for 105. I think on all of them actually. I think they're all 105 degree caps, so they're good quality caps and they're going to last many years, so we won't be having the same problems as this one. Where do you start? I mean, the problem with this board is I've got lots of shields over things, and you know, sure enough, underneath those shields are capacitors, so they're going to have to come off. You know, I'm always a believer of doing the hardest first and then it gets easier from there on. So that's what I'm going to do, I think. I'm going to hit this big board. I've changed a couple capacitors, but I've only put in sort of cheapy ones I had in my box, so I'm going to change them for higher quality ones of the right size as well. And I'm going to get cracking with all these others. They're tiny little capacitors, so I've got to be careful of polarity as well. All good. Anyway, I'm going to be using my desoldering station, not desoldering station, but well, I suppose it is really. Desoldering the Duratool. Still going strong, put another tip in it the other day. Where are we? Down there, so you can't see it very well because my my magnifying light's in the way, but oh well. What's a thought? Yeah, there he is, and peeping in underneath there. So I'm going to be using that one. I've got to turn the power on because I had to turn all the power off again as usual because I was trying to tune a radio up. So well, I'm going to crack on with that, and I'll let you know how I'm getting on. Okay, just while I'm doing this, I've just had a thought. There's so many caps in here, and they're all black and they're all the same size. So how do you keep track of what you've done or what you haven't done? So I've got my list here of the capacitors that I had to order up and the sizes of them. So there's, as you can see, there's quite a few. So what I'm going to do is I'm going to cross them off as I do them, because I've written the capacitor numbers in there. So I've just done number 90, which C90, which is the 0.01. Done. Monotonous, but worth doing, believe me. Okay, just an update then on the recap. I'm about just over halfway through the board now. Got quite a few that I've changed already. There's been some tricky ones, some really tricky ones. There's a couple that are really close in this area to some surface mount resistors, so the solder sucker has to be really careful to suck them up. There's one over here. I just really don't know what this rubbery coating is on here, but I've had to cut a patch out of it to solder that one in because it's actually underneath this rubberized coating. So I'm really not sure why they've done that. It's obviously something to do with the ICs there. Yeah, I don't know why they've done that. Strange, they've just done it in certain areas. Anyway, I might drop a bit of wax in there just to reseal it up afterwards, or clean it up with some isopropyl. I've done all the work underneath this shield now. I hope. I'm just double check that a minute. So I had to take this shield off to do a lot of it. Yeah, they're all done now. So that's the next step, is to pop this shield back on. Then I'm going to crack on with the other half of the board. Well, you can see I've popped the other shield back on now. and I've had to take this one off, but I've never seen a shield with so many tie points. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 solder points on that shield. Dear oh dear, they don't make it easy for us. Anyway, that's now revealed another part of the circuit board. This is the VCO area by the looks of it, on the markings on the board, VCO2. So I've got plenty of capacitors in this area to do, all around here, so I'm going to get those done now. Okay, well that's the main board finished. The shields are all back in. I've put some wax in that bit that I cut out for that one. But that shield there was a pig to get back in. Absolute pig. All the caps are now done on the main board. Every single capacitor, electrolytic anyway, all replaced with high quality caps. No leftovers there. Bit of a task, and probably 4 hours into that on capacitors alone. So it only leaves one capacitor on the LED board to do. Just there. And there's a few on this one to do. 1, 2, 3, 4. I've already done one. So I've only got 5 capacitors left to do. Happy days. Okay, well, as I said, the recap is complete. So what I thought I'd do next is go through all these little capacitors. Literally tiny. One of them's pinged across the room somewhere. I can't find that one. Just have a look and see if there was any culprits there. Anything that might have stopped it working properly. So anyway, I'm going to crack on with that, and I'll just let you join me if I find any bad ones, really. Okay, well I've been through them all now. Overall, I would say the ESR is pretty high on all of them. You know, if it's a good capacitor, it usually gives 2 beeps. Borderline is 1 beep, and then is failed. And I've only had 4 that have failed. Strangely enough, they're all the same capacitance, 4.7. Now, for example, I've just connected up. I've only got one of these left, actually, a brand new 4.7. And that's coming out, if you can see that or not. Yeah, you should be able to see that. So I've got an ESR 2.6 ohms. It's only given 1 beep because it thinks it's a bit high, but at the end of the day, the lower capacitances usually do have a higher ESR. So let's say that's 2.5. Let's check. Ooh, let's check one of these 4.7s that came out of the Sony. So that's got an ESR of like 5.6, and it's given like that noise. No good. It's strange. Those are all high. The 4.7s. So that one's 6 ESR. So yeah, I don't know whereabouts in the circuit these were. Should have made a note really. They're all high ESR. 5.6. No battery. Oh well, that's enough of that. So I've got to change the battery now. But yeah, that's really the only ones that were bad, was the 4.7s. 10 microfarads, they were reading between 3 and 4, which is quite high. I haven't got any 10s left because I bought 10 and used 10, so I can't use one as comparison. But anyway, it's all recapped. I've got all high quality caps in it, and you know, when you look at the capacitors that come out of this, all the 10 microfarads are all Nichicom. I can't see any manufacturer's markings on the others, but I'd assume that probably the majority are Nichicom. I mean, there's a couple that I changed there, but yeah, the ones, I think there's a Rubicon there, Nichicon, so it really is high quality caps they've used in this radio to start with. probably why they last so long, really. As I say, these don't go wrong very often. Unfortunately, this one's had a drop, which might be coincidental that it's playing up. But I'm going to get it back together now and give it another test to see where we go. Okay, well, I've powered it up, and still no different. In fact, possibly even worse than it was before. But I'm just having a look around the board again, and I found this. This is like the RF gain controller. As you can see, it is very wobbly. And actually, it has got dry joints on all three connections, or certainly broken joints anyway. So I'm going to have to solder them back on and see if that makes any difference. But yeah, that is the RF gain, so I suppose if that's open circuit, then nothing's going to get through, so bear with me. Okay, I've been messing with this radio for hours and hours now. I've remade most of the joints because for some reason, there we go, we've got, it works fine now, no problems at all. I can adjust the channels up and down. Just mess around with it a bit more.
Texas 8th London news. And you might have seen the video of a runner helping a stranger over the line in yesterday's London Marathon. David Wyeth started to collapse with 200 metres to go before Matthew Rees stepped in.
Oh, sorry, my power keeps dropping off it.
There may have been others, but you persisted, and I told you to go and you still didn't.
This is Newsbeat, back at 12:45.
Now, if I get down to here, which is the crystal, and tap it, gone. So, I mean, I've remade the joints on it. Whether it's just gotten weak, so I probably need to get into the service manual and just have a look at the voltages and the frequencies, because you've got a little trimmer here. So I've got to check that, make sure there's no legs broken on that IC, but I can't see any anywhere. I've remade all the joints on it, so anyway, yeah, that's the next plan of attack. Tune off of that onto some speech.
Things are changing in Paisley. If you look very, very carefully, really keep an eye out, keep your ears open, you can spot that there is a slight growth in support for the Scottish National Party. Now you can understand what may have made some of you annoyed to get to that point where the government...
So that's marked as X2 on the board.
Oh, lovely Scotland, please don't leave us, we love you so much. We want only to...
So I'm going to have a look at that one now, just see what that does. Let's just get this power off a minute.
And then when it looked like you might...
So I'm running out of ideas on this one. It's definitely something to do with that area of the board. Like I say, I can't really see anything physically wrong with it at all. I've remade all the joints on that IC. I've remade the joints on the crystal. So I need to see if I can get my frequency counter to look at the frequencies in that area a minute, just see what I'm expecting. Well, just having a look at the schematic here. Well, this is like the schematic layout. IC4 is PLL1. Typical. I just had a feeling it was a PLL thing. So the crystal in question is down here, X2. It says I should have 6.25 megahertz. So I'm just going to go and check to see if I've got my 6.25 megahertz on that one a minute. It does help have a nice proper service manual for it as well. Right, let's get my probe sorted out, bear with me. Okay, well as you can see I've got quite a bit of stuff hooked up now, and I think I found what the problem is. Well, I'm pretty sure I have. So basically on the IC we have got an unlock pin 8. Goes up to the unlock. So when it's failed, I've actually got, I don't know if you can see this or not, but when it's in fail mode, I've actually got 2 volts on pin 8. So that must be telling the processor that it's in an unlock condition and not letting it come on. With it working, I've got 0 volts on that, so that really is the only major difference between the two. The other thing is the frequency of that. Now, what I think it is, it's the actual oscillator crystal, the little canned crystal. Now, whether I can get one or not. So if I give it a few flicks. Not a very scientific method of doing it, I suppose, but let me just show you then in its unlocked state. I've got loads of stuff connected up here. I've got my oscilloscope connected. I've got the frequency counter. I'm not sure if you can actually see that. Probably you might be able to see it a bit better like that without the light shining on it. You can see I've got a couple of multimeters. I'm only using this one actually at the moment. Hopefully you can see that. So yeah, basically on pin 8 at the moment, which is the unlock, I've got a good steady reading on it. I've actually got 2 volts. I don't know if you can see that or not. I'll just zoom in a little bit so as you can see the meter. If you can see that, if that's any better. Yeah, so if I pin a probe pin 8, I've got 2 volts now. In the service info it says I should have 0 volts on that. So if I can get this thing to unlock by
Slightly more complex.
There we go.
Mixed developments where you've got housing associations over there, you've got ex-local authorities.
That's just my lamps and everything making that squealing noise.
10 years ago built here.
If I go back again to pin 8.
That is an interesting and diverse community.
It is. I mean, one of the benefits of developing science
0 voltage.
is that we can create a very rich local community in mixed 10 years, and we can genuinely deliver mixed and balanced communities where you have people accessing affordable homes for the first time as first-time buyers, people going up the home ownership ladder, growing families.
So if I
across the world that are renting in,
I'll also show you the frequency a minute.
Definitely.
At pins 5 and 6 now, absolutely nothing. And if I can get it to come back in again,
be able to build those houses from. Those are the bigger issues.
oh, what a game.
You think then that there's no, this is just not true?
See, 6.27476, so 6.275. Near enough.
But you think it's just not true?
It's not true that we're prioritising those bigger developments. Bigger developments.
So that's got to mean that
pressure on infrastructure, so there is a need to make sure that most development is on big
that crystal
sites. But that's not to say that it's a priority. I'm a councillor as well as being leader.
it's causing it to go out of lock. Oh, what a game. Cut myself off short then. As I say, I'm just going to have a look at the spec on that. I'm pretty sure it's if I can find it, X2, you know, it doesn't tell me, it just says it's oscillator crystal with a Sony part number. Okay, so we'll put the power off to it now. Power off to all the other bits and pieces that I got powered on. Hopefully that's got to the bottom of it. There was various other bits and pieces that were wrong with it. I found some dry joints. The RF gain control was dry joint. All three pins of that were broken, so whether that was part of the fall. I found a capacitor that was very high ESR. So I'm going to get all this apart now and just have a quick look at that crystal, so bear with me and I'll get you in on the crystal. Okay, I've got you in pretty close there actually. This is the culprit. You can see it's marked 6.275. As I say, just tapping that just knocks it out of oscillation or brings it back into oscillation for some reason. So there must be something loose inside the can itself. Whether that was caused by the fall or not, I don't know. And I mean, the frequency going in is pretty much bang on. There is a little trimmer there. I'm sure that's just to trim it to the infinite. I mean, it's got to be pretty accurate, to be fair. So, as I say, it's going to need to be changed. So I'll see if I can find one. Let's say it's, if you can see, if I can turn it round. Yeah, you can just see it there. It's X2 on the board. Probably not in very good focus, but that's the boy. So I'm hoping that's it. It certainly looks that way because tapping that will bring it on. I can't really see anything else back from that it could be. And I did manage to find a block diagram which confirmed that pin 8 was the unlock voltage.